Hello everyone, welcome back. This is Engineer Hussein Mwasapi, and in this video we'll be looking at material science and engineering. Alright, so before we begin, don't forget to like and subscribe to the channel. Alright, in the first part of material science and engineering, our first lecture will cover what is known as the classification of materials. Alright, let's begin. Now, we need to understand what material science is. And material science is simply just the study of the relationship between the structures and properties of materials. Now, with this in mind, we then have to understand what material engineering talks about. Now, material engineering is simply the study that involves creating or engineering the structure of a material to create a specific set of features that will be based on these structure property connections that we have. So let's not forget that. So as engineers, we can convert materials into goods that the society needs by using the knowledge from the material science and material engineering. Now this would describe the material knowledge spectrum. So in simplicity, all we're trying to say is that material science is simply just the knowledge about the structure and property of a material. Now that we acquire the knowledge, we're supposed to apply it in our day-to-day lives through engineering. So now that's where we have to now create structures or materials that will meet the needs of the society. So let's not forget that. So that is what material science and engineering looks at. Now, one thing you should know is this, that when it comes to structures, a structure in materials is defined as the arrangement of the internal components of a material. So the way the internal components are arranged in a material is simply what is known as structures, and structures are in types. We have the first type, which is known as the microscopic structures, and these have structural features that can be seen with our naked eyes, like you can literally see the structural features that it has. Then after that, we also have what is known as microscopic structures. Now, microscopic structures are these structural features that cannot be seen with our naked eyes. And the last type of structures that we have in material science is the subatomic structures. Now, subatomic structures contain electrons within individual atoms as well as interactions with their nuclei. So let's not forget that. Now, with this said, we need now to look at what property is. Now, all materials are subjected to some external stimuli that leads them to react in some way, and this defines the material's property. Now, for instance, a specimen can be subjected to some stresses that will make it deform, and you'll find that a polished metal surface will reflect light. So in terms of the nature and strength of the reaction to a particular imposed stimulus, a property is a material's behavior or response to that particular stimuli. Remember, stimuli, these are just factors that will cause a response. Therefore, it's clear for us to say that the definition of properties are usually given without considering the shape and size of the material in question. Now, with what has been discussed, it's best to look at how we can group solid material properties. Now, solid materials will exhibit different types of properties. So let's try and group these. Now, the first property we can look at is the mechanical property. Now, the mechanical property characterizes the solid material's ability to show what would happen if an applied load was subjected to it. So, characteristics of a solid material that explains how it behaves when subjected to some external forces or stresses will describe the mechanical property that we're trying to highlight. So, among us, the most frequent mechanical properties we have, we can look at the following. The first one is strength. Now, strength, this is defined to be the ability of a substance to sustain external forces without permanent deformation. Now, tensile strength, compressive strength, and shear strength are examples. Other than strength, we also have stiffness. Now, stiffness is the resistance of a material to deformation when subjected to an applied force. Okay, so let's not forget that. So, the ability of a material to resist deformation is called stiffness, and in most cases you'd find this to be represented as K. Now, The Young modulus or elastic modulus is frequently used to quantify this stiffness. Other than stiffness, we also have what is known as hardness. Now, hardness is a material's ability or capacity to withstand surface indentation or penetration. It indicates how resistant a material is to wear or scratches. Like if I try to scratch a material, now is it going to be scratched due to the applied force, or is it not going to be scratched? Now, the measure of the resistance, to wear or scratching is what is known as hardness. Now, other than hardness, we also have ductility. Ductility is simply just the ability of a material to deform under tensile stress without fracture. Okay? Now, it describes how far a material may be stretched or pulled into a wire-like shape. That's why you find that in most cases when you're using the term ductility, you're trying to look at how a material can be drawn into something that looks like a fine wire. Alright, we also have what is known as brittleness. All these are mechanical properties. Now, brittleness is just the exact opposite of ductility. Now, when stressed, brittle materials tend to fracture. Fracture simply means to break without significant deformation. Let's not forget that. So, brittleness just describes the ability of a material, or the measure at which a material will simply just break. So let's not forget that. So it's literally the exact opposite of ductility. Alright, now that we have discussed those, we can also look at toughness. Now, toughness is simply just a combination of strength and ductility. It assesses a material's ability to absorb some form of energy and plastically deform before fracture. Now, these that I've just mentioned are just a few examples of mechanical properties that describe how a solid material behaves. We also have now what are known as electrical properties. Now, electrical properties will show the behavior or the characteristic that's related to the flow of electric current or the presence of an electric field. Now, let us now look at some common electrical properties of a material. We have what is known as conductivity, the ability of an electric current to flow through a material. You'll find that we have certain classes of conductors that will allow electric charge to travel easily, but the quite opposite of conductors are known as insulators or dielectrics. Now, on the other hand, they have a low conductivity and restrict electric current flow. Other than conductivity, we have what is known as resistivity, which is quite the opposite of conductivity. Resistivity quantifies a material's resistance to the flow of electric current. Now, other than that, you'd find that we also have what is known as a dielectric constant, also known as relative permittivity. Now, this is a measure of a material's ability to store some form of electrical energy in an electric field. So, be mindful that when exposed to an electric field, it determines how well a material can polarize or store charge. Then the other one we can look at is dielectric strength. Now, the highest electric field that a material can withstand before electrical breakdown occurs is referred to as its dielectric strength. It is a measure of the material's capacity to withstand high voltage without failing. Now, other than that, we also have the semiconductor behavior. Now, some materials have properties that are intermediate between those of conductors and insulators. These substances are known as semiconductors. Now, by adding chemicals or modifying the temperature, they can be managed to adjust their electric conductivity. Then we can look at the last one, which is piezoelectricity. Now, this indicates that the material has the ability to transfer electric energy or waves into mechanical energy or like sound energy. Now, reversed piezoelectric converts sound to electricity in the reverse direction. Now, these are only a few instances of electric qualities that define how solid materials will behave, and you'd find that there is actually a vast majority of others. Now, what I want us to look at is now the thermal behavior. Now, the thermal behavior is just a response or characteristics when subjected to changes in temperature. Now, how a material behaves when subjected to some form of heat or some form of temperature. Now, here are some key aspects of some thermal behavior of solids. We have thermoconductivity. Thermoconductivity is an example of a thermal behavior. It is a measure of how well a material conducts heat. It measures a material's capacity to transfer thermal energy via conduction. Metals have high thermoconductivity and are good at transporting heat. On the other hand, insulators have a low thermoconductivity and are good at blocking heat flow. Now, other than that aspect, we can also look at what is known as thermal expansion. This refers to a material's tendency to expand or shrink in response to changes in temperature when heated. Most materials will always expand and contract. Now, the coefficient of thermal expansion determines the magnitude, or this is the size of dimension change that occurs as a result of temperature change. The time we'll be looking at these properties in detail. We'll look at how best we can calculate this coefficient of thermal expansion. Now, we also have what is known as specific heat capacity. Now, the amount of heat energy needed to increase the temperature of a unit mass of a material by specified amount is specific heat capacity. Now, it describes the ability of a material to store and release thermal energy. Now, with that said, we can look at the melting and boiling points. The melting point of a solid material is the temperature at which it transforms from a solid to a liquid state, while the boiling point is the temperature at which it changes from a liquid to a gaseous state. These temperatures are material specific and provide information regarding thermal behavior during phase transitions. Now, when we talk about phase transition, we're just talking about the changes of state. Let's not forget that. Then we also have thermal stability. Thermal stability refers to the material's capacity to resist high temperature without decomposing or changing structurally. Now, it indicates the highest temperature at which a material may be used safely without degrading it. Alright. Now, the next property we can look at are the magnetic properties. Now, the magnetic properties demonstrate how a material reacts when a magnetic field is applied. Some examples of magnetic properties we can look at is simply magnetization. Now, magnetization is the ability of a substance to become magnetized or display magnetic behavior when exposed to an external magnetic field. Materials are classed as paramagnetics, which are weakly attracted to a magnetic field, diamagnetics, which are weakly repelled by a magnetic field, or ferromagnetics, which are strongly attracted and capable of retaining magnetism even when the external field is removed. There are several types of magnetic properties that are under magnetization that we'll look at the time we'll be looking at magnetic properties in detail. Now, we also have what is known as magnetic permeability. Now, this is a material's ability to enable magnetic flux to flow through it. It expresses the speed with which a material can be magnetized. Let's not forget that. Then we also have magnetic susceptibility. Now, this is simply just a degree of magnetization that a material can undergo when exposed to a magnetic field, and it will always describe the material's response to a magnetic field. Then we also have the carrier temperature. This is the temperature at which a ferromagnetic or ferrimagnetic substance loses its permanent magnetic characteristics. Now, the substance becomes paramagnetic above this temperature. I'll explain this in detail the time we'll be looking at the magnetic property in detail. Alright, so we also have what are known as hysteresis. Now, this is just the lagging or the delay in the material's magnetization caused by a change in the external magnetic field. Now, it occurs in ferromagnetic materials in most cases, causing them to retain some residual magnetization even after the field is withdrawn. Alright. The next property we can look at are optical properties. Now, this describes the way a material responds when subjected to light or electromagnetic radiation. Now, this will include some optical properties like opacity or transparency. Transparency, we use this term in our day-to-day life quite often. Now, transparency refers to the material's capacity to transmit light without significant absorption or scattering, enabling a clear view of objects through it. Contrary to that, opacity, when we say opaque, describes a substance's capacity to obstruct light, making it challenging or impossible to see through it. The next one that we have is absorption, which describes a procedure through which photons or light particles, as we mostly like to prefer, are absorbed by the substance. Then we can also look at reflection. Reflection is the bouncing back of light rays from a material's surface. The direction and intensity of reflected light depends on factors like the angle of incident and the surface property of the material. Then we have refraction, which is simply just the bending of light as it passes from one medium to another with different optical properties. Then we also have scattering. Scattering, this is when light meets with microscopic particles or imperfections in a substance. It changes direction and spreads out in different directions. Now, this phenomenon causes a variety of visual phenomena, including diffused reflection and the blue color of the sky. We'll look at scattering and other terminologies that are quite vast and optical properties, and we'll get to understand exactly how this works. Then we also have what is known as I guess you've heard of the term luminance. So when it comes to luminance, we're trying to talk about the emission of light by a material after it absorbs energy from an external source. This occurs in different forms such as fluorescence, which are short-lived emission, or phosphorescence, which are long-lived emissions. Alright, now we also have what are known as deteriorative properties. Now this shows the behavior of a material when subjected to reactions with its environment, especially with oxygen. And it just talks about how the way a material will react when it's subjected to an environment. Is it going to corrode, or in what way is it going to deteriorate? For example, we can look at corrosion. Now, corrosion is just a chemical interaction that happens between a material and its surrounding environment, resulting in a material's degradation. We'll get to understand corrosion the time we'll look at it in details. Alright, so these are the 6 properties that we have of solid materials, and that's how they are grouped and classified. All those properties are going to be explained one at a time in detail. For now, we're just looking at the surface of those properties. Now, let us look at 2 terms that are mostly used under material science and engineering, which is processing and performance. When we talk about processing deals with the manufacturing and shaping of a material. That's if we want to achieve a desired form. But if you look at performance, this one just focuses on assessing how well the material performs and how well it can meet specific demands or expectations in its use. Now, you need to take note of something. Every time you're trying to select the right material, you have to consider 3 factors. This is a very important note that you have to know. When selecting the right material, you're supposed to consider the following. The first is the in-services, which is the strength or the ductility. In short, the mechanical property of the material. Then, the next thing you're supposed to check is the cost of the product. Is it an affordable choice? Then lastly, we're going to consider the deterioration of a material. Now, in other words, we're trying to talk about the effects that it will have due to the exposure with the environment. Now, with this said, we can now just jump into the 4 disciplines of material science and engineering. Now, there are 4 disciplines that we have, and this is the PSPP. Now, the information you get from a material is all described in the PSPP: processing, structure, property, and performance. Now, this highlights everything you need to know about the disciplines of material science and engineering. So, For today, we'll just end here. In our next video, we'll look at the type of materials that we have under material science and engineering. Thanks for watching. Don't forget to like and subscribe. Remember, my name is Engineer Hussein Mwasapi. If you have any questions, you can reach me on WhatsApp on the number attached to my description. And remember, small progress is better than no progress. And let us strategize before we become a statistic so we can push for that A+.